So, hey guys, bring in your friends also. Okay, we will starting in just a minute. So let's just have a conversation. Arjun, you also could unmute your mic and let's start. Yeah.
Hello,
So, hey, yeah, how are you?
I'm fine. How are you?
Yeah, cool, cool. Yeah, fine. So excited about the event now.
Yes.
So, anything special do we have for this session then? Like, what are the output of the session? We could just have a light conversation right now.
First of all, in the last 5 to 10 years, the field of machine learning and deep
Mm-hmm.
learning has immensely grown. Daily, there are new inventions going on, new research papers being published. So, to understand these new things, you must have a good base, a strong base to deal with.
Mm-hmm.
If you don't have a strong base on basic things, you cannot understand these research papers and all. Okay, if you don't have a good base and if you still start going on at after some point you can't go any further, so you have to come back to start from basic.
So the
So
basics,
it's
yeah.
good, yeah, so it's good to start from a basic and get all the things clear. So
Yeah.
in this session, I will try to build a good strong concept so that it
Mm-hmm.
will help everyone who wants to start their career in machine learning.
Okay, cool. So you are basically helping us create a good foundation for machine learning and then grow upon that. Okay.
Yes, yes.
Yeah. Okay, cool. So we have about 10 to 12 people live right now. So let's just wait for people to get up to 15 to 20 people. You guys, the chat, you could start commenting, start asking your questions. We would be addressing that too. And also, you could start sharing the link to your friends so they could also learn about machine learning. And of course, uh, yeah, enjoy the session. Okay. Yep. So apart from that, what are the new things which like machine learnings are like new things happening in machine learning right now? Any new trend going in machine learning? Because I have seen in the last couple of years, like people are directly jumping to deep learning and XYZ. Even my college project was on machine learning, even though I wasn't very much confident on how I am building the machine learning. We usually try to fork from GitHub and add it. So it's kind of bits and pieces of other machine learning modules and XYZ things. So how do you encourage people to learn machine learning right now?
While learning machine learning, there are actually two parts. One is the theory and the conceptual part, and the other
Hmm.
one is coding part. Basically, you are implementing your knowledge in code. So
Hmm.
there should be a proper 50-50 balance between theory and code.
Okay.
For theory purpose, for any model you are learning, for example, you are learning neural networks, let's say. So
Hmm.
you must understand how it works and why it is working as it is.
Hmm.
So if you don't know that, then if you also because code is available everywhere on Google, you can
Correct.
easily copy paste and run the code. But to get a higher accuracy, you must tweak the hyperparameters to get a reasonable accuracy. For that, you must
Hmm.
understand what parameters is what. So for that, you
Okay.
must understand the basic concepts.
Okay. Cool. Okay. So we have about 19 people live. So let's start our session. Let me just share my introduction and all the things. Okay. So yeah. So guys, my name is Raj Dedania. I professionally work as a product designer, and in the last 3 years, I founded Design and Code, and uh, yeah, so it's been a good journey. We have been doing so much over here, and like in Design and Code, and uh, I'm excited to share more of that after the session, or you could ask it on the comment section also. Okay, so this is kind of a short introduction. You could connect me on LinkedIn over here. It's I could just find my name. I guess there is only one Raj Dedania right now. Okay, so let's talk about today's session. So we usually used to have a weekly talk, but what we are trying is right now getting experts on our platform, and this time we have someone special on our platform right now. So we are changing it basically to expert thoughts by design and code. So yeah, so today's for people who don't know what design and code is, we are an open community for creators believing in learning, sharing, and creating. So what does that mean? So basically, we bring a platform for creators where they could explore their raw talent, they could explore their projects, and they could just learn from each other. And we are doing it in so many different ways, basically providing them free resources, providing them with free workshops. Sessions like this would help them. And also, we are planning to bring in more things in future. So this is kind of a small introduction for design and code. And today we would be learning more of basics of machine learning, as we were discussing in the first part of the video, where it's important that we create a good foundation for machine learning and then scale our knowledge and implementation accordingly. So and this is kind of a special moment for DNC. We have partnered with ML Guru, and Arjun is the founder of ML Guru. ML Guru is basically a YouTube channel where he is teaching and talking about machine learning, and soon he would be launching talks and sessions on deep learning also. So I would encourage you guys to follow ML Guru. All the links have been given in the description also, so you could just read that thing. Let me just give a short introduction for Arjun over here. So Arjun has been like working in the machine learning field for, like, I guess for 2 and 3 years. So he is kind of a person who would inspire people to learn machine learning. And just to give a small achievement list and achievements he have achieved during his time, we basically got a long list over here, but I would just highlight couple of achievements. One is, if you guys are familiar with hackathons organized by ISRO and Smart India Hackathon. So there was a problem statement given by ISRO, and only two teams from India were selected for solving the problem, and one of the team member were from Arjun, and one of the team was from Arjun's team. Apart from that, he has been giving talks on YouTube, and also he has given a full day session on deep learning in our international conference, which was organized in Ottawa College. Okay, and also it's a great thing that he is in the top 5 of NPTEL's Python course right now. So of course he would be talking about his projects and details and more of a detail in his introduction. This is kind of an introduction from my side, Arjun. Once I give the presentation to you, you could add more information towards that. So yeah, so basically, we also have this thing kind of from the last couple of sessions, that you could basically start tweeting and adding stories. These are our basically handles over there, and we do have a special gift for best stories and best tweets. So guys, do tweet and add stories to your platforms. And since this is our first YouTube live, so pardon me that if it's anything going wrong right now. It's our first session, and of course we would be learning from this thing. So you could basically, I would encourage you to ask questions in the comment box, and so that accumulate that thing, and we would ask our expert over here. So yeah, let's start the session. Okay, Arjun. So I would be handing the presentation to you now. 1 second. Yeah, Arjun, you could start sharing your slide. But
Okay.
before that, I would just want to ask you, can you just add few things on how did you started your machine learning journey, and what excited you over here?
Okay. Okay. So I was in second year.
Mm-hmm.
So I had developed my interest in the field of machine learning, but I didn't know anything about it. So first I searched what are the prerequisites I need to learn to go forward in machine learning. So first thing is which programming language to use. So many people say that Python is the best right now. So I learned Python from the same NPTEL course you mentioned,
Mm-hmm.
and I was ranked in top 5% all over India in the exam. And
Okay.
from after that, that was just the basic core Python skills. And after
Okay.
that, you need to learn the scientific libraries in Python, such as NumPy, Pandas, Matplotlib,
Mm-hmm.
and all. So you can do the scientific computations for machine learning. So
Okay.
after you have this Python and all the scientific libraries learned, then you can jump into machine learning. So for machine learning, the first course which I took was the Andrew Ng's famous course on Coursera.
Mm-hmm.
So there he taught all the basic things. Then
Mm-hmm.
after that, I implemented the theory knowledge into code using various resources such as YouTube, Google, and
Mm-hmm.
also many other platforms were there. Also PDFs. And
Okay.
after that, I started my journey in deep learning. Basically,
Oh.
I took a 5 month course which was provided by IIT Madras
Mm-hmm.
on deep learning. So
Okay.
just last month, I have completed that course, and
Okay.
now I'm exploring various fields in deep learning, such as natural language processing, computer vision. There are a lot of things going on, and it is very difficult to learn all those things. So I am exploring the different areas in the deep learning.
Okay. So you mentioned that you were in the top five. So just that everyone and like in the community feels that they should be in the top five or top of the course. So is it so? Just to ask, of course, you are a scholar over here, but is it difficult that I would say to get to learn Python or to start with Python?
No, it's not difficult. You just have to maintain your focus.
Mm-hmm.
If you understand the basic things right, you get it in your head, then it's very easy. You must understand just two things: how and why this code work.
Okay.
So if you get the answer of these two things, it's very easy.
Okay, and basically you mentioned at having a focus. It basically means that you should have discipline in learning the things. I myself,
Yes.
like I'm a designer from a developer background. So for me, learning new language was a bit difficult, and because I wasn't very dedicated and want to learn this programming, like I just like started learning XY many programming language together, and then it just bursted out. So any guidance you want to give people to start learning about Python, like before we start the session?
So what I did was first I tried two, three languages like C, Java, and all,
Mm-hmm.
but I was not able to, get comfortable with it. So when I started learning Python, I felt that it is a very easy language. It's just like you how you speak English. You have to
Mm-hmm.
just type it as it is. So its
Okay.
syntax is very easy. It is very easy to learn, and there are lots of tutorials available on Python. So
Mm-hmm.
once I got started, it was very
Easy to continue from there. Okay,
yes.
cool. So yeah, Arjun, you could start sharing your slide, and I would just give you the whole presentation. So thank you guys. You could start commenting your questions over here. I would be collecting the questions, and I ask Arjun while we have a break in between. So yeah, Arjun, take this. Yeah.
Okay. Can you see my screen?
Yeah, Arjun, yeah, we could see your screen.
So let's get started with machine learning. So the very first definition of machine learning was given by Arthur Samuel in 1959. He basically told that we define machine learning as the field of study that gives computers the ability to learn without being explicitly programmed. Right. So it is very clear now what this term explicitly programmed means. We will see it after some time. But now let's move forward. So this is a diagram in which you can see the outer circle is the entire artificial intelligence, and machine learning is just a small subset of it. And deep learning in turn is another small subset of machine learning. Many people think that deep learning and machine learning are two different fields, but it's not like that. Deep learning is a small subset of machine learning. In deep learning, you basically focus on neural network architectures. That's it. So the next standard definition was given by Tom Michel. He basically told that there is a task T, and the performance measure of your computer program on that task is given by P. Then if with experience E, your performance measure P improves on that task, then it is nothing but machine learning. Now let's understand the difference between traditional programming approach and machine learning programming approach. So in traditional programming, we give two inputs. The first one is the data, and the second one is a set of rules. So you can think of it as you are writing a basic function in any language. So while defining the function, you first give some arguments, which is the data, and inside the functions you write some set of rules. Now, given this data and set of rules, you get some output. But in machine learning, the first input is the data, and second input is the output which you desire to get. And given this data and output, you get output as some set of rules. Now, if you have rules, you can pass to it some new data, and you will get your predictions on it. And machine learning is all about making predictions. Now, let's see a task. You are given a picture, and you have to. Your task is to identify whether this picture contains a cat in it or not. So, what if I tell you to write a traditional program? Traditional program is nothing but writing if-else block. So what if I tell you to write this if-else block code to identify whether a cat is present in a picture or not? Will you be able to write the code? Now suppose you are very expert and you somehow wrote the code. Okay. But what if I change this picture? The same code will not work on some other picture, right? So this is what you call it as explicit programming. But in machine learning, you don't need to write this traditional programming. The computer itself learns the pattern. So what you do is you collect bunch of images in which some of them contains cat, some of them does not contain cat. And with each image, you also tell your computer that see, this is an image of a cat. See, this image does not contain cat. And when the computer goes through the images, then it itself understands the patterns in the images and itself uh, it's able to predict on unseen pictures that whether this picture contains a cat or not. So isn't it amazing? Now let's talk about another example. So suppose there is a doctor and he wants to write a traditional program to classify a patient whether that patient is infected by coronavirus or not. So what he will do for each patient, he will ask some set of features. Now, in this case, the features are whether the patient is having fever, is having cough, is suffering from any breathing problem, or suffering from vomiting. Now, given these features, basically in form of yes or no, he will write this if-else block. For example, if he has only fever, then he's not infected. If he has fever as well as cough, still it is not infected. But if he has fever, cough as well as breathing problem, then yes, he is infected. And this code will give output as yes or no. But from where did the doctor get these rules? By his past experience. But what if there may be some complex combination of these features which may lead to coronavirus, but the doctor is unaware of that combination. So it won't work in that case, okay? But in machine learning, what we do is we first create our data. In this, you can see each column is a feature. So there are the features are fever, cough, breathing problem. There may be many such features and vomiting. And the last column is the actual label of the patient, whether it actually was infected by coronavirus or not. So your 0 means it was not infected by coronavirus. 1 means he was infected, right? So each row here denotes a single patient, right? And 1 denotes yes, 0 denotes no. Now, if we pass this data to an untrained machine learning model, initially the model is untrained. When you pass this data to an untrained model, it will go through the data many times, it will find the patterns, and then it is trained. Now, once it is trained, you pass some unseen features of patient. And then based on these features, it will give the output as yes or no. For example, this is a set of features for a single patient. He has just fever, and the rest of it are 0. So it will output as 0, means the patient was not infected by coronavirus. This is another example. In this case, depending on these features, our model has outputted yes, this patient is suffering from coronavirus. Now, let's talk about why machine learning is very successful today. The first thing is there is huge amount of data today we have on internet. We can scrape a huge amount of data. It is said that data is fuel for machine learning. Your machine learning model will be as good as the quality of your data. The second thing is you have variety of models for various types of tasks. Like classification, you have n number of models. For regression, you have n number of models. You have this neural network, you have SVM, you have many such things, right? And you don't have to really understand in deep about all this model. You can easily use it for your purpose because you have various libraries pre-built in programming languages like Python, wherein you just pass your data and it will do all the computations on its own, and you will able to use this various types of model. The third thing is today you have fast and cheap computing devices. Back then, before 50 years, the devices were expensive and also they didn't have that much computing power. So it was very difficult to train the machine learning models. But now, given fast and cheap computing devices and also cloud services like AWS or something, you can very easily train your machine learning models. Now, the basic six elements of machine learning are data, task, model, the loss function you are using, the learning algorithm you are using, and how do you evaluate your model. So if you understand these six things with respect to any model you learn, you basically understand the entire model. Okay. Now let's talk about data and task. So you can see you have data in various forms like structured data, image data, text data, video data, and audio data. But before passing it to training to a machine learning model, it must be converted in numeric form. Okay, so there are various techniques in which you can convert each of this type of data into numeric data. Now let's see another example. This is a classification task in which you are given the CT scan image of brains, and you have to identify whether that brain is diagnosed with tumor or not. So your 0 means it does not have any tumor, 1 means it has tumor. So your data is basically divided into two parts. The first one is the X and second one is the Y. So the X are the feature, okay, basic features. So in this case, these features are nothing but the pixel values of the image. If you have a 50 cross 50 image, so there may be 50 cross 50 pixels. So these are nothing but all the pixel values. And this Y column is called the true label, that whether that brain has actually had a tumor or not. So given this, you train your model, and once your model is trained, then you can pass an unseen image and it will predict whether that image has a tumor or not. But suppose I not only want to classify whether that brain had tumor or not, but I also want to detect the region where the tumor is. Then for that, this data will not work. You have to modify your data. So to represent a rectangle, you need four coordinates: the lower left coordinates and the upper right coordinates. So in your data, you must extend your true labels and add these extra two columns in which you also, if the patient is diagnosed with brain tumor, you must also pass the coordinates of this box so that your model will learn from it. And once you train your model on this type of data, if you pass any unseen image, it will not only classify whether that image has a tumor or not, but it will also locate the region where the tumor is present. And if you don't have any true label, then if you only have just images, then you can do nothing very special with this data. This comes under unsupervised learning. So what is supervised learning? What is unsupervised learning? This is basically the classification of machine learning. So what is supervised learning? In supervised learning, along with your features, this is the X which I had mentioned, you also pass the true label. For example, in this task, I have bunch of images of fruit and I want to classify which fruit it is. So with every picture of the fruit, I also mention which fruit they are. So once my model is trained, if I passed any unseen image, it will predict the correct fruit. Now in unsupervised learning, you don't have any true labels like this. You just have images. So when you pass such data to your model, what it will do is it will group similar type of images. So for example, this data has only three types of images: apple, bananas, and peaches. So it will find similar images and will group together. This is called as clustering. It comes under unsupervised learning. Now here is an example of supervised learning in which we are dealing with the task of classification. So in this, given the tumor site and the age of the tumor, you have to predict whether that tumor is malignant or benign. Okay, so as you can see, I have plotted, so these two columns are my X, this column is my Y, the true label column. So I have here plotted all these data points. Your circle means the benign tumors and a process means the malignant tumors. And once my model is trained, you can see this line. This line is nothing but my machine learning model, which is trying to classifying these two classes. So if I give any uh, new tumor, I will pass the tumor site on this axis, I will pass the age of the tumor on this axis, and whether it falls on left or right of this line, it will classify whether that tumor is malignant or benign. The next task is regression, which we are dealing in this session. In this, you can see the first column is your X, which contains only one feature, which is the area of your house, and this column is your true label, which is basically the actual value of these houses. So as you can see, I have plotted all these data points over here in this graph. And unlike the classification, here you see your true class contains zeros and ones or discrete classes because it's just classification task. But in regression, your Y contains real value numbers. So basically, you can see I have trained my machine learning model, and the curve which you can see, which fits on this data, is nothing but my machine learning model. And now, if I want to make some prediction, let's say I want to predict the house price, which has an area of 1,000 meters square. So I will calculate the price based on this curve. Okay, so it is something around 40,000. Now, coming to unsupervised learning, uh, clustering is one of the tasks in unsupervised learning, which I had talked just now. So in this, you don't have your Y column, you just have your X features. So here you can see you have X1 and X2, and these are all are the points in this data set. And as you can see, my model has grouped similar clusters in this data. So it has found three clusters in my data, and it has grouped into three different groups. The other task, sorry, this is unsupervised learning. The other task in unsupervised learning is this generation task, in which you just pass bunch of images of something, like for example in this case you pass bunch of human images, then it will learn the patterns in the images, that how a human face look, and after it has learned, it can generate fake images of human. So this image is a fake image, but it looks very real. This is generated by a model. Now let's move forward to linear regression. So as I
Yeah.
told,
So Arjun, one second. So just to get a whole concept of the first module correct. So we just discussed about how supervised learning is done and how unsupervised learning is done. So for the viewers, just can you just brief in just a small paragraph that how do you define both the things, and what are the major differences in the both?
okay, so in supervised learning, in your data set, you have your column, X columns, as well as your true label column, which is the actual output for all these data points. But
Mm-hmm.
in unsupervised learning, you just have your X column. You don't know what this means. So in unsupervised learning, your model just group similar kind of data, similar types of data. But most of the problems in real world deal with supervised learning data, because
Mm-hmm.
that's very meaningful. You can't do much with unsupervised type of data.
Is it because we basically constrained it for our output, like we optimize it for our output?
Yes, because in unsupervised learning, we don't have your actual Y column. We don't know what the data means and what is my task. But in supervised learning, we know we have defined our task that whether this image contains cat or not, whether
Mm-hmm.
this CT scan image has a brain tumor or not. So we are telling our model that yes, this image has diagnosed with tumor, this image has not. So it
Oh,
learns the pattern. But in unsupervised learning, you are not telling anything about the data. So
mhm.
what it can do?
Okay, cool. Cool, Arjun. Yeah, you could continue. I would just add that. Yeah.
Okay. So let's start with linear regression. As I told you, first we will deal with the data which has just one feature. As you can see, your X contains just one column, and as usual, your Y column. These Y columns are the real value number, as you can see, because we have to predict real valued numbers, unlike in classification where you had discrete classes. Okay, so let's remember some notations. So your M denotes the total number of data points or the total number of rows in your dataset. N denotes the total number of columns in X. In this example, our X has only one column. So my N is equal to 1 in this example. And if I have to represent a row, then I can represent it by Xi by I, where I denote the row number. So for example, what is x2 comma y2? So your 2 means your second row. So if you see your second row, these are the values for your second row. Now let's plot this data. So on the x-axis you have your x column, on y-axis you have this y column, and you can see all of the data points in your data set. So in linear regression, what you do is if we train this model with a linear regression model, what it will output is this straight line. As the name suggests this line is linear. Okay, so it will output a line which perfectly fits the data. As you can see, this line is fitting my data, and this straight line is nothing but your linear regression model. And suppose I want to predict the value of y for x is equal to -2. As you can see here, I can simply predict like this. So here you can see my prediction lies somewhere between 0 and 2.5. Now the model is a straight line. So the equation of a straight line, as you have learned in your school, is nothing but y is equal to mx plus p. So remember one thing, I am denoting the actual y with this y, and I'm denoting my prediction using y hat. Okay, so whenever you see this y hat, this is nothing but your prediction. So this is my equation of a straight line where m is the slope and c is y-intercept. But in machine learning, we do not use this m and c. We use two types of parameters. The first one is w, which is known as the weight, and second one is b, which is known as the bias. So suppose you have three different models, and the three different models output three different straight lines. So how can you identify the best? So the best line is the one which is best fitting the data. But how do you define which line is fitting the best on your data? So the line for which the average distance between the line and all the points is minimum, that is the line with best fit. So in this example, you can see the red line, the average distance between all these points with this red line is minimum. So this red line is your best fit line. Now let's see how our model uh, defines that what is best fit, what is not. So for that, our model uses a loss function. So for example, this is a straight line fitted on this data. So let's look at this particular point. For this particular point, the actual output was this, which is somewhere around 0. But the prediction made by my model is somewhere around 1. So it has made some error on this point. Similarly, it I can calculate the error for all of my points. Okay. Now see here my loss function. So for every element, I am defining the error as the difference between the predicted value and the actual value. So here you can see yi hat minus yi. So what this means is the error for a single data point. Here I denotes your row number. So this difference gives me this error. But to avoid negative values, we square it. Okay. So then you sum this error, the square of the difference error for all your points. As I told you, m denotes the total number of data points. So we will sum all this the squared error loss for all of my data points. Okay. And as you can see, this loss is called as the squared error loss. All right. Now sometimes people also take the average. So you are not only summing up the loss, but after summing you also take the average. So this is called the mean squared error loss. And sometimes people also add here 2. And we will be using this loss for our task. Now why we add here 2, it will be clear after some time. But remember this loss function. In here, y I had is given by this equation, which is nothing but an equation of a straight line. So for any point, if I want to make prediction, I will use this formula.
Y- Yeah, Arjun, we have a couple of questions before you move ahead. So,
Okay.
Riddhi was asking that is this the perpendicular distance? I guess she is talking in the about the previous slide.
So is she talking about this distance?
Yeah, she was asking that is it a perpendicular distance? Riddhi could add more a detailed question over there. Before that, she also asked that where we were discussing supervised and unsupervised learning. Okay, so she
Okay.
asked that as you said, supervised learning is more used, but the computation complexity of unsupervised
Mm.
learning is less than the supervised learning. So she wanted to want to learn more about it. So she asked that can you add some points to it?
Okay. So today in real world problems, 99% of the problems are solved using supervised learning. First, you
Mhm,
have your data and your task clear. Let's give you an example of unsupervised learning. So suppose you have a manufacturing company where you design t-shirts for a particular city. So what you can do is if you want to define let's say 3 or 4 sizes of your t-shirt like XL or L, S, M. Okay, so you have to define some measurements for each of these sizes. So what you do is you collect the data for all the people in your city and you just pass to your unsupervised learning model. Then it will group similar kind of people based on the size. So suppose your model finds 4 clusters, so you can create 4 sizes like S, M, L, and XL. Okay, so this is where you use unsupervised learning.
okay, cool. Okay. Yeah, you could continue it as and when question pop up to according to the context of the slide. I will just ask you over.
Okay. And the
Yeah,
next doubt which one person had is
yeah,
what is this error, right?
yeah.
So you can see for let's look at our data. So here you can see with for every point in X, you have the actual value of Y. So this is your true value of Y, as you can see in this diagram.
Mm-hmm.
And your predicted value of Y is the one given by this straight line. So here, as I given you example, how you make predictions, you just extend this point on your line and then uh, look at the value which it points on y-axis, or otherwise you can use this formula. You have the value of m. Basically you have your value of w and b, which is learned by a model. You have to just pass on the value of x, for example here -2. So when I pass -2 here, I already have learned the values of w and b. You will get some prediction. So the
Mm-hmm.
difference between your actual value and this predicted value is nothing but your error.
Okay, cool. Okay, I guess your question has been answered over here. Okay, Arjun, you could continue. I'm just closing my.
Okay. Okay, so we have defined our loss function. Now let's recap all those things. We have our data, and what we do is we randomly initialize W and B before training. Okay, this is before training. So when you randomly initialize the values of W and B, you will get an equation of a straight line, and this is the straight line which was randomly initialized. So for this, just look at our data. This is the x column, this is the y column, and these two will not change because this is already given to us. Now for each of my x, I also calculate my predicted value using the using this formula. So I have basically three columns, and having this y hat and y, I can calculate my loss. And as you can see, my loss depends on the value of y I hat, which is my prediction. And my prediction is given by wxi plus b. So directly your loss depends on the values of w and b. Now we have to update our values of w and b such that the loss is reduced. So earlier look at this line. Now we somehow update the values of w and b. So you can see our line has changed and it is coming closer and closer to our data. And as this line has changed, you can see this column. This column has also changed because our prediction has changed. And we have updated the values of w and b such that the difference between y, the actual values, and the prediction has been reduced. So indirectly, your loss value is also reduced. Now we make another update to this, and as you can see, this line is the best fit. So for this particular prediction, your loss is the minimum. But now, what is the goal of doing this? We have to find the value of WN such that the loss is minimum. As in this case, we have somehow find the values of WNB such that this particular line gives me the minimum loss possible. So this is our goal. So the first slide has ended. We will move to our next slide.
Yeah, guys, if do you have any questions, you could add into the comments. Yeah, Arjun. Once you're ready, let me know. Yeah, cool. So, anything for any questions over here you would like to ask? I guess it's kind of easier to understand as and when he is approaching the context. Okay. Uh, so we have one
So can I
question over
continue?
here. Yeah, one
Okay.
second. One question. And what about the outer lines? Do we consider them as well? Like it might change the value of loss. I guess she's asking again for the previous slides. So I will
Okay.
just
As you
repeat the
can,
question. Yeah.
so this line which you can see is the output given by my model because we have changed the value of w and b. So when we change our line, basically when we change w and b, our line also gets changed because the equation is getting changed. Now once our equation is changed, this column will also change because y I hat is given by this particular formula, and as our w and b has changed, this last column will also change, and also the loss will also change. And as we are updating the values of w and b such that the loss is reduced, the difference between this y and this y hat will also get reduced. So directly our loss, which contains the difference. So this difference for all my points will get reduced, and overall my loss will also get reduced. And the goal of this is to find the value of W and B such that my loss is minimum.
Okay, cool. So let's continue further. You could just yeah.
Okay. So this is the recap which I have just discussed.
Mhm.
Now what we will do is, this is my loss function, and this loss depends on the value of y I had, and y I had depends on the values of w and b, which are we updating. So what we do, as you can see in this figure, we try all the possible combinations of this w and b. So you can see the first axis contains w, the second axis contains b, and for all possible combination of w and b, we plot the loss. As you can see, for a particular value of w and b, we will get a particular value of loss. So we just plot the loss values, and we will get a surface like a bowl, as you can see. And as you can see in this surface, uh, wait a second. In this surface, you can see there is a minimum value lying in the center of this bowl. So our goal is to reach this point where my loss is minimum. As you can see, the z-axis contains the loss. So at this point, my loss is minimum. So again, do the same experiment. We randomly initialize the value of w and b. So here we have initialized the value of w to somewhere around 20 and the value of b somewhere around minus 20. Now, for this particular combination of W and B, our line looks something like this. Our prediction looks something like this. Now, our target is to reach this minima. This is called as the minima of my loss surface. Now, how do we reach there? We have to obviously update the values of W and B. But we want our model itself to update the values of W and B. So how will it update? One thing which we can do is we will use the slope of the surface to get towards this minima. So basically, anywhere we are in this loss surface, currently we are here, we will find the direction where the slope is the steepest. So that direction is nothing but the direction which will provide you the fastest way to reach towards the minima. So what we'll do is we'll step in that direction. As you can see, once we step, this line also changes. All right, and since for this particular point the loss is uh, lower than this point, so you can see the difference between this line and these points has also got reduced. See, so we can do this multiple times until we reach this minima. So as you can see, once using the slope, we have reached this minima. We got our line of best fit. And another thing to observe is as we are using the slope to take the steps, you can see initially where the slope was steeper, the update size was large. But as the slope is getting gentle, my update size is also becoming slower as to converge towards the minimum. And this algorithm is known as the gradient descent learning algorithm. Now, this is the 3D plot of my loss surface. You can also plot a corresponding 2D plot. So what this plot is you are looking at this surface from top. So this is nothing but the top view of this surface. And we can similarly view the results over here as well. Okay, so as you can see from the figure, this is the point where my loss is minimum. So I have reached this point. Now next what we will be doing is we will go behind the mathematics of gradient descent algorithm. So we will do it in two parts. First, we will understand the basic mathematics, and then we will apply this knowledge to our linear regression model. So what we have is we have a function f of z, and it's just a simple function z squared. And for values of z, I have plotted this graph. So this is a simple graph of z squared. And our goal is to find the value of z such that fz is minimum. So you can relate this with our problem. So you can relate this fz to our loss, and this z is a parameter which I have to change such that the value of fz is minimum. Okay. So let's do the same experiment again. We randomly initialize the value of z. I've initialized it to -2, and this is our target where the loss is minimum or fz is minimum. Now, as I told you, we have to use the slope to update the value of z. Now, as you know, the slope for any curve at any point is given by a tangent to that point. So this tangent which I have drawn depicts the slope of this curve at this point. And mathematically, you can calculate the slope of the curve by differentiating it with respect to z. So the differentiation of z square is 2z. So here we have visualized the law. We have visualized the slope as well as we have calculated the formula for our slope. Now next, since you can see this negative slope, okay, so basically these type of slopes are positive slope, and these types of slopes are negative slope. And you can calculate this by substituting the value of -2 in the value of slope. So when we substitute -2 here, so 2 into -2 gives you -4. And here as well, you can see that our slope is negative. So given that our slope is negative, what do we do with our x? Should we increase it or should we decrease it to reach the target? As you can see from this figure, we have to increase the value of z to reach our target. So we have to increase the value of z. So in short, what you have to do is you have to move in opposite side of the slope. So basically, if you have negative slope, you have to increase the value of z, and if you have positive slope, something like this, then you have to decrease the value of z. All right. And in mathematical form, this can be represented using this formula. So the new value of z or the updated value of z will be the current value of minus the slope. This derivative is nothing but the slope. So this formula tells us that we are updating z in opposite direction of our slope. So this minus sign tells you in that you are updating z in opposite side. So I have highlighted this formula over here. Now let's substitute the value of the slope which was -4. So you are updating like old value of that minus slope. So your slope was -4, and this gives, we also substitute the current value of z which was -2, and the new value of z is 2. So let's update, look at this figure, we are updating the value of z, and now your z has moved from -2 to 2. Now let's apply the same procedure again. Now here you have positive slope, so you have to decrease the value of z. We calculate using this formula. So the new value of z is -2. Now when we repeat the same and same, then you can see that we are just oscillating back and forth of this minima, but we are not reaching this minima. Why? Because my update size is seems to be larger. So we have to somehow control the update size or my step size. So for doing that, what we do is, in the formula of our update, as you can see here, we multiply the value of slope with a value which is known as the learning rate. This is nothing but any number. For example, you can use numbers like 0.5, 0.1, 0.01, and so on. You can use any of this value to control your update size. So for example, let's use the learning rate of 0.1, and while updating the slope, we will multiply this 0.1 with our slope. And hence now look at this figure. When we update, see here, my update size has become small. Okay, so now when I repeat this procedure for n number of iterations, I will basically converge towards this. Now further we will see a visualization when we repeat this step for 10 iterations. So you can see here, I have learning rate of 0.1, and I am doing this update for 10 iterations or 10 times. Then you can see I am slowly converging towards this minimum value. Now what we do is we let's try decreasing the learning rate. So here you can see I have decreased the learning rate to 0.01, and I have kept the number of iterations as same. But in this case, you can see the updates are very slower compared to the previous one. So in this case, I may have to increase the number of iterations to give this the time to converge till here. Now let's increase the learning rate. Now I have set the learning rate to 0.8 for 10 iterations, and you can see within 6 iterations, it is converging towards this minimum. Okay, but you can also see that it is oscillating back and forth, but it is actually converging. Now, what if I further increase the learning rates? Let's see. So now I have increased the learning rate to 1.1, and you can see that this learning rate, instead of converging here, it is diverging from the minima because the learning rate is very high. So we have to set a learning rate such that it is not very small, not very high. We have to set a learning rate at somewhere around 0.01. It depends on your problem, but you have to try different values of learning rate so that your convergence will happen smoothly. And here you can see the side by side comparisons of all the learning rates. Okay. Now let's move to part 2, where we will apply this knowledge to our linear regression problem. This is nothing but a linear regression single variable problem because our x contains just one column. Okay. So here you have your data. Here you have your predicted value. And as told earlier, this is my x column, this is my y column, the actual y's, and this is my predicted values. This was my loss function, and we have to minimize the loss. And as I told you earlier, the loss depends on the values of w and b. So earlier it was z because the function f of z, which was given by z square, was only depending on the value of z. But here my loss depends on two values, w and b. So we have to update both these values, and here you can see a slight change that instead of calculating the derivative, we are calculating the partial derivative. Now why are we doing so? Because the loss function is a function with two variables, which is w and p. So in this case we cannot calculate the derivative with respect to a single variable. We have to calculate the partial derivative. Okay, and this is my update rule, which I will be using to update the values of w and b. And when I do it for n number of iterations, it will my loss will get reduced, and I will get the line of best fit. So let's see how do we calculate these partial derivatives. So here you have a loss function which depends on y I hat. The formula for y I hat is this. And now we have to calculate the partial derivative of loss function with respect to w. Okay, so we just substitute the formula for loss from here. So this is my loss, and as you can see, this 1 over 2m is a constant. So we can take this out of my derivative. So what I have left with inside the derivative or the partial derivative is this thing. Now if you notice, this is actually a sum in which this is a summation in which you have m terms, each term belonging to a single row, right? And there is a rule in calculating the derivative that the derivative of sum is equal to the sum of derivative. For example, you have to calculate the derivative of this thing, which is a sum of two functions. Then what you can do is you individually calculate the derivative of these two things and then add them. So the same rule we are applying. So we take this derivative inside individually to each of the terms, and you can see we have applied this derivative to each of the term. We have expanded the summation series. So you can see that all the terms are identical. The only difference is we are calculating this for all my rows. So your number 1, 2 up to n denotes the row number. Okay. Now let's see how do we calculate this the derivative for the single term. Once we know how to calculate this for the single term, we can generalize it for all these terms. Okay.
Arjun, over here, before you continue, there are a
Okay.
couple of questions we got right now.
Okay.
First, I would like to add a serious question and then add one question which kind of a journal. So one question was about how to overcome overshoot problem when gradient descent is high.
Okay. So suppose you try out with value like let's say 0.01. You initially try with a low value, like 0.01, and see your loss, how monitor your loss as your training happens, and see that whether your loss is decreasing or whether it's increasing. If it's increasing, means your value is overshooting. All right. On the other hand, if you see that it is decreasing but it is very slow, so in that case you can just increase the learning rate. So from 0.01 you can increase to 0.05, and then again monitor your loss. Okay, usually by default it is set to 0.01 or 0.001, which works mostly for many cases.
Okay. So I guess this answers your question. And one more question we have is This is kind of a question I would also ask is, uh, can I start writing machine learning code without caring of maths and theory of ML algorithm? I hate maths and I don't know maths. So can I become a ML engineer? So I personally am not very much good at complex maths where calculus is involved. So is it compulsory for young ML learners and developers to learn maths first?
So, if you don't know maths and you don't want to learn maths, then you can just take the intuition that what this formula does instead of how this formula does other things. So you can just take the intuition that how it is working without knowing the implementation details. So for those who are not comfortable with this calculus and all, you can just uh, watch this and just take the intuition of what it is doing rather than how it is doing.
Okay, cool. Okay, I believe that your questions are answered. Arjun, you could start.
Okay. So let's see, we take any ith term from this summation series. So here we have any ith term from this series and we have to calculate the partial derivative of this with respect to w. Now, as you can see, my hat is equal to this thing. So let's substitute it here. So now it is very clear. We have to just take the derivative with respect to w. So all this thing, first we apply the power rule for the square term. So as you can see, we have applied the power rule and then we differentiate the inner term. So all this thing becomes zero because we are differentiating with respect to w. We are only left with this xi. Or if you don't understand this, and also once you get this, you can substitute back the value of w xi plus b back to y I had. Or if you don't understand this, then you can use the chain rule. So you are doing is what you are doing is nothing but first you take the derivative with respect to y I had, and then the derivative of y I had with respect to w. So as you can see here, this is nothing but a simple power rule formula. So I have applied this power rule, and after that, the derivative of y I had with respect to w. As you can see, if I differentiate this with respect to w, this thing becomes zero. I only left with xi. So you get the same thing over here. Now, similarly, if you do this for b, now see this term will be same. Only here you have to calculate the derivative of y I had with respect to b. So this thing b will become 0 and the derivative of b with respect to b is 1. So here instead of xi you have just 1 only. Alright, and see the initial terms, this 2 times y I hat minus y is same for both this term. Only here it is multiplied by xi and here it is 1. Now look at here, we had this summation. We know how to calculate for this single term which was given by this formula. As you can see here, 2 times y I hat minus y times x hat. So I am substituting the result for every term. Only the value of I is changing from 1 to m. The rest of it is same. And you can see I can take this 2 from each term common and cancel it out with this term. Okay. So that was the reason why we had introduced this 1 over 2 in my loss function to cancel out this and simplify the terms. Now, after simplification, this is what our dou L by dou W looks like. And similarly, our dou L by dou B looks like this. Instead of x1, x2, xn, we have 1 over here. Now, uh, this was our training data. This is the plot of each of my data point. Now let's look at the pseudo code that how we can implement this in Python. So what was the first step? Randomly initialize the values of w and b. So we do this by using the numpy's function that np.random.random for both these two. This will basically initialize the values of w and b to any random numbers. Now we set the number of epochs. The number of epochs is nothing but the number of iterations. We set the learning rate to 0.1. Now what we do, for we apply a for loop, which means for each iteration, for 20 iterations, first we initialize this, sorry, first we initialize this dou L by dou W and dou L by dou B to 0. So I am denoting this my dw and d and I initialize it to 0. And inside this outer for loop, I'm applying another for loop in which I'm going to each of my row individually. So you can do this by for x comma y in zip capital X comma capital Y. So this capital X capital Y denotes this entire data set, and this small x small y denotes each row individually. So for each row, I'm calculating my prediction, which is given by wx plus b, the equation of straight line. Then I'm accumulating the value of gradient, these terms. So this is for the first row, this is for the second row, so on up to the last row. So at a time, I'm calculating this term for a single row. So you can see I'm calculating this for first row. Then in the next iteration, I will come to second row. I will calculate dwdp and I'm accumulating the sum. As you can see here, we have to accumulate this sum for every row. And after we have done it for every row, we have to take the average. As you can see here, we have to divide by m for both dw and d. So actually, I have repeated this two times. This is actually db. Okay, the first one is dw, the second one is d. So you have to divide both these terms by m and then use our gradient descent update tool to update. So as you can see, this this update will run for 20 times because we have set the number of epochs to 20. So our um, the parameters w and p will get updated 20 times, and after the update we will get this line. And one more thing, one pass over the entire training data is called an epoch. So as you can see, we are calculating this for first row, second row, third row. So when we calculate this for all the rows, it is called as one pass over my data. And that is nothing but one iteration or one epoch. And the parameters w and b are updated once per epoch. As you can see, this is my outer for loop, and for each loop, the values of w and b are updated just once. Now we have to set appropriate values of the number of epochs or the number of iterations and the learning rate, which are known as the hyperparameters, which we have to tune so that our training gives best performance. Now let's look at some disadvantages of this gradient descent learning algorithm. So you update your parameters W and B just once per epoch. Now this was just a toy example. Now suppose you have a data set with millions of entries. So you may pass over millions of entries and update your parameters W and P just once. So this would consume lots of memory and lots of time. So this is one of the advantages. Also the second one is this algorithm is used to converge towards the local meaning. Now, as we have seen in case of linear regression, the loss surface was a bowl shape. So in that case, we have just one minima, and in that case, our gradient descent will work fine. But suppose you have loss function, something like this, which in which you have multiple minimas, like one over here, one behind this mountain. Now, suppose I initialize my W and B somewhere around here. My goal is to reach the global minimum, but the gradient descent algorithm will converge somewhere around here. It will get stuck in my local minimum. So before using this gradient descent algorithm, you must make sure that your loss has just one minimum. So this was our bowl function for our linear regression, and this has just one minima. So this type of loss function are called as convex function, where you have just one minima where you can converge. And this type of loss function where you have multiple minimas is called as the non-convex function. So while using gradient descent, you must always use the convex loss function. Now that was lots of theory. Now let's implement this in Python. So here you can see in code we'll also write the code and also visualize these animations. So let's get started with the code.
Yeah, Arjun. So Yeah, before we start with the code, anything you want the viewers to focus on while you are coding? Like, what should be the output of the whole coding session, so that they have a context of what they are expecting as output.
So see, I am basically coding in this Google Colab notebook, which provides
Mm,
free Jupyter notebook instance on Google
mm,
Cloud. So it is
mm,
free to use. So once I write the code, I will share the links of this code to all of you, so you can go through that after the session is completed, because we have limited time and we have to
mm.
cover lots of concepts. So what I will do is, after each code I will comment that what this particular line is doing. I will go through it now, but if you want to go in detail, you can, after the session you can run this notebook for yourself and see how it is working. Because we have limited time, we
Yeah.
cannot go into much detail in it.
Yeah, cool. So what we would do is we would add all the links to the description, and also would be sharing that same thing on mail also, so that you have a reference for yourself to learn from. Okay, so handing over to you, Arjun. 1 second.
So as you can see, this is my Google Colab instance. So first of all, what we will do is we import libraries. We import NumPy, Pandas, Matplotlib for plotting, Seaborn is also used for plotting. Then this is some basic settings, and these are all also for visualization. So let's run this. You can see here our the CPU is getting initialized. It is connecting to Google Cloud. It is initialized, and now it is connected. Okay, I'll zoom a code little bit. Okay. So first we are defining the number of points in our training data. Basically, we are generating random points for our task. So we generate our x column by using this numpy's random function. So we generate n points and having just one feature, and we calculate. We define y as using this formula. This is any random formula I have used. And now let's print the shape of x and y. So as you can see, my x column is of, basically x and y are two arrays. X is of shape 100 comma 1 means 100 rows or 100 data points, and one column because it has just one feature. And y is also 100 rows corresponding to each of the values of y and one column. Now let's visualize the data. So I have visualized the top 5 points in our data set. So you can see this is my x, this is my y. Right, these are real valued numbers, and let's plot the data using matplotlib. So you can plot using this code. You can group plt.scatter x comma y. This will basically plot each of this x y pairs here. So each point corresponds to a single row over here. Now we have to fit a straight line on this. So for that I have inserted the formulas which we just discussed in the slides. So we have to implement these formulas in our code. All right. So let's define some help functions. So the first function I am defining is to compute the y pred. So given the value of x, w, and b, I will compute y pred as wx plus b, which is very simple. The second thing, the second function is to compute the loss for a single point. Okay, not for all of them, because you can see a loss. I am calculating just this term for every point. So first, what I will do is I give the input of the prediction from here. I give the actual value of y. So this is my y hat, this is my y, and I calculate the difference y hat minus y hat. I take the square, and this 0.5 is nothing but this 1 over 2. I'm inserting this inside the summation. All right, and this is for a single data point. Now the next function is to calculate dou L by dou W. So given y pred, y, and x, we calculate by this formula, which is nothing but this formula for each term separately. Okay, and similarly for b, using this formula, let's run this. Now we are setting the number of epoch. I have set it to 30. I have set the learning rate to 0.1, and I am storing the number of rows which is given by x dot shape of 0. So you can see here x dot shape is a size of 100 comma 1. So the first value is the number of rows, the second value is the number of columns, which is 1. We are interested in the number of rows, which is 100, so we index it by 0. So my m contains the number of rows. Now we initialize the values of w and b. Here I am initializing to -4 -4. You can initialize it to any random value. Now to visualize how my loss is working, I am creating this empty list. So basically after each update, I will store the updated values and loss in this array. So I have created an empty list for loss. I am created an empty list for storing the updated values of w, and similar for b. And since we have initialized these random values, we have appended the random values, initialized values of w to w hist, b to b hist, and we are storing the initialized loss in this loss. So how do we compute the loss? So first we are calling this function compute y, which is nothing but this one to calculate my prediction. So this will give me my prediction. Okay, and we will call compute loss function for each of my element. And as you can see, the capital X is an array. It is not a scalar value. It is array of size 100, 1. This Y is also an array of size 100, 1. So the output of this thing will also be an array of size 100, 100 cross 1. Right? And then we call this compute loss function. So the each element in this array, it will also be a size 100, 1. Each row will correspond to loss of that uh, particular row. Okay. And now once we have computed the loss for all of my data points, we have to just take the sum, because as you can see, we have to sum this loss for all of my data points. We sum and then take the average, because we have to divide it by m over here. So this is the way we calculate the total loss, and we append to this empty list. These are the initialized values. So here you can see my history values of W, D, and loss. So initial loss before starting the training is 65.4. Now, now we will. This is the main training loop. So for we will loop for number of epoch. This is the same pseudocode we had just seen. So I won't explain in much detail. So we calculating the prediction. We are accumulating the gradients for each of the rows. Then we take the average and then update the values of W and B. And then since the values are updated, I need to store the updated values in this tree list so that I can later on plot the values. So first I store the loss using the same thing which we did here. The only difference is now the values of W and B are changed. And we append the updated values of W and B in this W list. And this last thing, it has nothing to do with this code. This is just I'm converting this list to NumPy array so that it will be helpful while plotting. So my training is done. You can see it just took 1 second to train. Now we will plot our final result. So first I'm plotting my data points earlier as I did. Then I'm plotting my prediction. So you can plot the predictions by plt.plot. Your x value is all your data points. This wx plus b is your prediction, and this w and b are the latest updated values. Okay, we are plotting it in the red line. So this red line is my final value, is my final output of the model. This is my model of linear regression, which has been fitted on this data. Now let's visualize the loss. So this is the thing which one person has asked me the doubt, that how do you know that whether the loss is overshooting or not. So what you have to do is you have to plot this graph, which is nothing but On x-axis you have the number of epochs, on y-axis you have the loss. Since I had stored the loss after each update, I can plot this. So you can see my loss is constantly decreasing, and here you can see it is getting flattened. So here I noticed that yes, it has converged. And if your learning rate was higher, then instead of decreasing, it would have increased. Okay. So in that way, you can identify whether your learning rate is right or wrong. Now your linear regression code has been completed over here. All the code after this is just for plotting the animation. You don't have to know the details of this. So I'm just running it. You have to just look at the animation. So this is our first animation. It shows that how our model is getting updated after each epoch. So this initially we initialized randomly the values of W and E. This was our initial line. Now let's see how the model learns. So as you can see, after each update, my line is getting closer and closer to my data, and it is fitting on. So after 30 epochs, this is what we get our output. You can also increase the number of epochs to get even more conversions. Let's move on to next visualization. So okay, here I am showing you two visualizations. One is the 3D loss surface, and the second one is 2D one. So first, let's view the 3D loss surface. So as you can see, this is our actual 3D loss surface for this problem. I had told you this will be of bowl shape. Yes, it is in a bowl shape, but we have just plotted some portion of it. Because if you plot the entire bowl shape, uh, it will take it will take time to load. Okay, so I am plotting just a region of this bowl. Our animation is getting ready, so let's wait for it. And also, along with this 3D loss surface, below the loss surface, I have also plotted the 2D contour of this loss. So our animation is ready. Okay, so you can see we are currently at epoch 0. This is my current loss. This is my initialized point. Now let's run the animation. You can see my W and B are getting updated, and it is converging towards this minimum. So this is how your gradient descent algorithm works. Now we can also visualize same for the 2D contour. So we set the 3D to false, 2D to true, and let's run. So here you can see this is the 2D contour. How to read this contour? Wherever the lines are close to each other, the ellipses are close to each other, that indicates that the slope is steeper. And where you can see these lines are far away from each other, that portion indicates that this is a gentle slope. And our goal is to reach somewhere around here. So our animation is ready. Let's visualize. So we start from here and we are converging towards this minimum. So we are done with the linear regression code. Now let's move forward.
Yeah, I hope that everyone is like understanding the code. Uh, I feel that it might be difficult to consume since you're not writing the code, but we would be surely sharing the code so that it's easier to understand while you are referring to the documentation. Okay, Arjun. Yeah, what's it? So, any questions over here, like while he was explaining the whole concept? We are waiting for your comments. So, you could add your comment while Arjun, you could start continue the session. Okay.
Oh,
Yep.
so till now we were dealing with the linear regression problem where your x just contained a single column. Just like this. In this example, your task is to predict the price of the house given the area size of the house. So here you can see your X contains just one column. In short, it has one feature. And in that case, your prediction was given by this formula. But now what if my X has multiple features? So this is an example where you have multiple features. So this entire thing is your X. So you have your size in feet square, you have the number of bedrooms, you have the number of floors, you have the age of the house. And based on these four features, your task is to predict the price of the house. And this column Y is the actual price of these houses. And X has four features too. And let's first know some notation. So yeah, M denotes the number of rows, N denotes the number of features. So you can treat this entire X as a matrix or an array of size M cross N, meaning M rows and N columns. Xi denotes the ith row of X. Okay, so for example, and each of the row can treat each row as a vector of size n, a vector containing four n elements, in this case 4. For example, x1 denotes the first row of x. So this is my first row of x. I can represent in this way as in vector form, and its size is R4, means 4 elements in this vector. And xij denotes the jth feature of ith row. For example, x to 4. So x to 4 means second row and fourth feature. So this is my second row and this is my fourth feature. So it is denoting the age of the home, the second house, which is 40. And earlier your prediction was given by Wx plus b. Now since we have 4x's or 4 features, each of these x will be associated with a weight. So for xi1 you will have w1 weight, for xi2 you will have this w2 weight, and so on up to n features. And as usual you have this bias term. Okay, so you can treat the weight also as a vector of size n. In this case, there are 4 features. So there will be 4 weights corresponding to 4 features, which are W1, W2, W3, and W4. And as I had told you, this Xi1 means first feature of ith house. It denotes the size. Similarly, the second feature is number of bedrooms, number of floors, the age of home. So remember these notations. And for example, if I had to make a prediction on this first house, given the values of W1, W2, W3, W4, which will be learned, and also the bias, I can give my prediction by W1 times this value plus W2 times this value plus W3 times this value plus W4 times this value plus the bias, as you can see. So you can see, yeah, this value is nothing but X11, which is the size feature of my first. Okay, so this is how you will make prediction on each of the rows. And this equation, okay, this is a new example in where your x contains two columns, x1, capital X2, and your prediction will be given. Your prediction for each of the ith point will be given using this formula, and this is nothing but the equation of plane. Earlier it was just wx plus b, so it was the equation of line. But as your dimensions of x increase, or the number of features you have, which is n, the equation of plane will also have that many dimensions. So this will be a plane in 2 dimensions. If you have 5 features, then it will be equation of plane in 5 dimensions, which is obviously hard to visualize it. That's why I first taught you the linear regression where we had just one feature, so that you can visualize it. Because when we go in higher dimensions, we cannot visualize it. Now let's see how we apply gradient descent for multivariate linear regression. It will be almost similar to previous one, so you will not have any problem as such. So this is my loss function. My loss function is same. Okay, there is no change. Instead, now my y ahead will have this formula which we have just discussed, and this is my w, and we have to let's say we have to calculate the partial derivative of this loss with respect to w1. Okay, So I substitute the loss here, the value of the formula of loss here. As before, we take this 1 by 2m outside the loss. This is a summation term. The derivative of sum is equal to the sum of derivative. So we apply derivative to each of the term in this summation individually. This is all the same which we had done till now. And let's see how we calculate this derivative for any I term in this summation. So this is any I term in the summation. We substitute the value of y ahead from this formula over here. And now we have to just take the derivative of this thing with respect to w1. So first we'll apply the power rule, and then we'll calculate the derivative of the term inside of it. Or easily you can look at the chain rule. This term will be same as previous. We are just using power rule. And when we calculate the derivative of this term with respect to w1, all this term becomes 0, and we are just left with this xi1, which is the first feature of uh, ith point, because we are calculating for ith term. Okay, and similarly for similarly for w2, uh, rest of the thing will be same, only it will be xi2, as you can see here. And for any jth weight, it will be the same till here. It will only be xij, and the partial derivative of this thing with respect to b will be same as it was in the linear regression with simple with single variable. Okay, because this thing will become 1. So this was our summation. We know how to calculate each of the derivative. Substitute this formula from this general formula for all of my i's. So you can see here the value. So uh, for generalizing, we are taking the derivative of loss with respect to any weight wj. It can be 1, 2, 3, 4. I am taking any weight j. So this will be xij, x1j, x2j, xmj, as we had seen here. For uh, w1 here, it will be xi1. For w2, it will be xi2. Similar for wj, it will be xij. Okay, now we take the two common from here as previous. We divide that with this two, and this is what we get. And the formula for dou L by dou B is same as previous, linear regression with single variable problem. Now, as you can see, it is very tedious job to first calculate this with respect to W1, then W2, then W3, up till Wn. But there is a way which is called vectorized gradient descent, in which we can calculate this partial derivative of loss with respect to all the W's at once. In a single go, you can calculate this uh, derivative, and you can at a time update all the weight simultaneously. So let's see how it is done. So I have written the general formula of the derivative of loss with respect to Wj, which is given by this formula. And now this is your data. You have your x, you have your y. Your x is just a matrix of size m cross n. Now I am doing some matrix operations here. You don't ask me that why I am doing this. It will be clear after some time. But focus on what we are doing. Okay, don't ask why we are doing. You just see what we are doing. So you have your y hat, which is of type m cross 1, which is nothing but the predictions for all the rows. You have this y column over here. It is also a size of size m cross 1. We subtract these two vectors, then you will get the vector of size m cross 1, in which each element is nothing but the difference between the predicted value and the actual value. So we get this matrix. Now what we do, this is our matrix we just got now. We'll take the transpose of this. So it will change from 1 cross 1 to 1 cross 1. We just flip it. Okay, this is our transpose y hat minus y. And now what we do is we multiply this matrix with this x. Okay, so you can see the dimensions. This matrix was 1 cross m, as you can see here. Our x is of dimension m cross n. And you can see for matrix multiplication, the inner dimensions must match, and the result which you get will be of dimension 1 cross n, which means uh, it will be of size 1 cross n, and it will just be a vector which contains n elements. Now let's see what these n elements are. Now, how do we do matrix multiplication? We select this row. There is only one row, so we select this row and we multiply this row with this column first. This is how we do matrix multiplication. Now let's look what it gives. So you can see here, what we are doing is nothing but we will multiply this first term in this row with the first term in this column plus the second term in this row times the second term in this column, and so on. So this 2104 is nothing but x11, this 1416 is nothing but x21, as I told you earlier. So look at this formula over here and look at this formula. Is it the same? It is the value of j over here is 1 everywhere. So it is nothing but dou L by dou W1, except there is missing this 1 over m here. But that we will take care afterwards. But if you ignore this term, you can see that this term is exactly same to this term for W1. Okay, so this first term here is nothing but dou L by dou W1. Similarly, the second element will be calculated by multiplying this row in the second column. And you can see the value of j changes from 1 to 2 over here. Rest everything remains the change. And this is nothing but the formula of dou L by dou W2. So if we do this for all the n columns, what you eventually get, and also we had to multiply this 1 over m here. So we multiply this by 1 over m here, and what we get is a vector of type n, where each value is nothing but the partial derivative of weights. So as you can see, with just this simple matrix multiplication, we can calculate the derivative with respect to all the weights in one go. Okay, and once we have done this, we can also update the weights at one go, because this was our gradient descent update rule. Earlier this w was just a scalar or just a number, but here w is also a vector, as you can see here. So w is of the size 1 cross n. So the new value of w is equal to the old value of w, which is also a vector, minus learning rate times dw, which is given by this thing. So you can see we can update all the weights w1 to wn at once using this update rule. So it saves a lot of time and it is also very fast. So before going to code, let's understand another important concept, which is known as feature scaling, which we have to do before implementing the multivariate linear regression.
Okay, so you guys, you could start adding your comments over here. I am like understanding it in a very easy term. Thanks, Arjun, over here to make it so simple. So yeah, so
Thanks.
if you are ready, yeah, Arjun. So handing it to over you. Yep.
Okay. So we will now start with feature scaling. So to recap, let's take this simple data set in which your X has just two columns, the size and the number of bedroom, and this last column is your actual Y column. Okay, and this was the formula for my prediction, which is given by W1 times X7. This just we see just now. Now from previous video, we saw that this was the general formula of derivative of loss with respect to any weight Wj, and this was given by this summation. Now you can see from here that this term depends on any ith term in this summation. Okay, so we will select any ith term from here. So we have wi hat minus w hat xij. We have just selected any ith term from here, and we can see that this depends on any item. Now in this case we have just two columns, so we have just two weights corresponding to two columns, which is the w1 and w2, as you can see here, w1 and w2. So with this formula, if I substitute the value of j to 1 and 2 for our two weights, you can see uh, this derivative term depends on this term. Okay. Now what is this xi1? It is nothing but the first feature of ith row. And what is xi2? The second feature of ith term. Nothing but the first feature is height, the second feature is number of bedrooms. So you can see that the first feature, which is the size feature, has values which range in thousands. So as you can see, it is 1000, 1500. So the values in this column ranges in thousands. Whereas the numbers in the second column is just a single digit value. It may be from like 1 to 10 at max. Okay, so you can see that the first term in both of these terms, which is the yi hat minus yi, will be same for both of these. The only difference between these two terms is this xi1 and xi2, where xi1 denotes the size, which will usually be in thousands, and xi2 will be in single digits. So obviously, you can say that the magnitude of this derivative will be very, very large than the magnitude of this second derivative. Why? Because the first term is same in both. It will be the second term will be multiplied by 1000 in this case, and here it will multiply it just a single digit. So you can see that the magnitude of dou L by dou W will be very, very high than the magnitude of dou L by dou W. Okay, so now this was your update rule. You are updating W1 and W2, and this update, as you can see, is proportional to this dou L by dou W1 and dou L by dou W2, which are nothing but the slope with respect to W1 and W2. And since the magnitude of dou L by dou W1 is very, very high than the magnitude of dou W2, the update in W1 will be very, very high than the update in W2. So this triangle denotes the update. Okay, the update in W1 is very, very high than the update in W2. And for such a data where all the columns the range of all the columns are different, if you plot the loss contour, which we had seen, you will get such a skewed contour or elongated contour. This is the problem of the data. Okay, and when we run our gradient descent on this, suppose I initialize the values of W1 and W2 somewhere around here, you ignore the bias term for now. We initialize the value of W1 and W2 somewhere around here, and when we run the gradient descent, it will update, and the updates will look something like this. It will be oscillating back and forth. And if I zoom just a single update, let's say from this initial point to this first update, I have zoomed in here. So the x-axis corresponds to W1, the y-axis corresponds to W2, as you can see here, W1 and W2. You can see the update in W1 is very higher than the update in W2. That's why you can see this oscillation. And this may also overshoot for you from your point of minimum. So this is a very bad thing in gradient descent update rule. So before running the gradient descent update rule, you must ensure that all the features like size, bedrooms must be in same range. Now, how we do that? Because size will obviously be in thousands, and number of bedrooms will always be in single digits. So, what technique we apply to scale all these features in same range is nothing but feature scaling. So, there are mainly two techniques to do this. The first one is called as feature normalization. It is also known as min-max scaler. It scales all the columns individually to 0 to 1. Now, the formula for doing this is, for in example, I have this number of bedroom columns. First, I calculate the minimum value in this column, which is given by 1. I calculate the maximum value in this column, which is 5, and I update every x using this formula, which is x minus x min upon x max minus x min. And this will eventually scale all of these values between 0 and 1. So for example, I have to change this phi using this formula, then the x squared or this x, new x will be given by x minus x min upon x max minus x min. If I substitute the value of x, which is phi, x min, which is 1, x max, which is also phi, x min is 1, you will see that the new value of this x is equal to phi is 1. And obviously, this is the greatest value in this column, so it it will eventually map to the value of 1. Similarly, for any other value, let's say take the value 3. If you apply the formula, it will get mapped to 0.5. Eventually, all the values in this column will be mapped in a value between 0 and 1. And I will do this for all the columns separately. So all the columns will be in range of 0 to 1. So there will be no problem of this oscillations over here. The second technique is the feature standardization. What it does, it scales all the features, all the columns to zero in an a unit variance. A unit variance means the variance of that column will be 1. And the formula to do this is x minus mu, which is nothing but the mean of that column upon s, which is nothing but the standard deviation of that column. Now we will see how to implement both of these techniques in Python. So we will get started with the code.
Yeah, so by then, you guys could start adding in comment. I guess it's getting a bit long, so let's see how we can continue it. You could continue with this coding session. Yeah.
Okay. Okay, so this is the notebook for feature scaling. Also, this will be provided you in the description box. So you can go through it. Since we are falling short in time, I will just go through it fast and I will just show you how to scale the features. So here I am importing some libraries, and also I am importing these two scalars, which just creates the min max scalar and the standard scalar from this sklearn pre-processing library. So you might have heard of this sklearn library, which provides you many codes to implement linear regression, multivariate regression, and which we will be using in this tutorial. Okay. So for now, we are just importing the min max scalar and standard scalar. And this is our data set. The link of this data set is given here. So I have read this CSV file in my pandas data set. So you can see the data set. So the I think we don't need this first column, which is just the indexing. We also don't need the transaction date. We need the house age. We need the distance to the nearest station. We need the number of convenience store, the latitude, longitude, and the last column is the true values of y. So uh, this part is nothing but our x, and this part is of y. So we have to separate this x and y. For that, we will use code. So we are basically splitting this entire data set into x and y. So this is how we do the indexing to select the rows and columns we want. And after selecting, if you have a look at X, we have 1, 2, 3, 4, 5 just in X. The house age, distance to the station, number of stores, latitude and longitude. And if you see the shape, it is of shape 414, 5. Means there are 414 rows in my data set and 5 features. And now if I plot each of these columns, I just want to see the variance of these columns, that where the values in all the columns ranges. Then you can see here our house age ranges from between 0 and 50. The second column ranges from 0 to 6,000. The third column ranges from 0 to 10. The third ranges from 25 to 24.94 to 25.02. Similarly, for the last column. So you can see all my features have different ranges. So we have to apply feature scaling. So this is the first technique to apply the feature scaling. So what we do is we create the object of this min max scalar, which we had imported from scalar over here. We create a new object known as sc1, and then what we do is sc1 dot fit for x. So what it will do is it will calculate the x min, x max, which we had discussed for all the columns of y x. And now the new scaled x I can get it from just C1 dot transform X. And if you look at the type of this scale, earlier it was a pandas data frame, but now after applying the feature scaling, it is a numpy array. So it has converted from a data frame to numpy array. And let's visualize the first 5 rows. So you can see every column over here is been scaled between 0 and 1. All right. And now if I plot the same graph which we had plot here after scaling, then you can see every column ranges from uh, 0 and 1. You can see every column is scaled between 0 and 1. Okay. Now next thing, the next method is standardization. So we create an object of the standard scalar which we had inputted from sklearn. We do the same. The scaled is given by sc2 dot fit transform of x. We visualize the first part. You can see every column in this data set is converted to zero mean and unit variance. And if you plot this, you can see all the columns have zero mean and unit variance. You can also check by calculating a dot mean. You see that mean is zero, which is e power minus 17, which is very close to zero, and the variance is 1. So this is how you scale. Now let's once we understood how we do feature scaling, now let's apply our multivariate linear regression to this data set. Okay, so the first part is the same which we had done till now, which is the scaling. I have written the formulas which we have to code. These are the same formula which we saw. So first we are using an object oriented programming approach to build this model. Earlier we were just defining the functions. Now we will define these functions inside a class. So we named our model as multivariate regression. The first thing in object oriented programming is define the init class, in which we randomly initialize the weight vector and b. And since you can see, I have defining w as a vector of size 1 cross n, those any random numbers. I am initializing b to 0. You can initialize it to any random number. The next function we define is to calculate the prediction, which is given by w1 x1 plus w2 x2 plus w3 x3 up to so on plus b. Okay, so this can be done by just multiplying your x with the weight vector and adding the bias. So if you see the dimensions, your x is of dimension m cross n, your weight is of dimension n cross 1. It was 1 cross n as you can see, but to match the dimension, I have taken the transpose. So it is 1 cross 1. And when you multiply, the result is of type m cross 1, which is nothing but your prediction for all the values of m. And we'll return it. The next thing is to calculate the loss. How we calculate? We take the difference between predicted and actual, we square it, we then divide it by 2n, which we were doing till now, and it will return a matrix of type m cross 1, which is nothing but the value of loss for each of my rows. But now we have to sum it, okay? Because of a loss is sum of squared errors, so we'll do p dot sum. And this will return a loss value, basically a scalar value. Now to calculate the gradient, we will be using this two formula. For that, let's define the m, which is nothing but the number of rows get by y dot shape 0. So m here is the number of rows in my data set. We calculate the y hat by this by applying this function. So we get this y hat, and we have to calculate now this dw, which is nothing but for that we have to just multiply these two matrices and divide it by 1 over n. So we do the same thing, y hat minus y dot transpose times x. I multiply this matrix using np dot matmul and then divide it by 1 over m. And that's it. We got all the gradients of dw, and we do the same thing for dw using this formula. It's nothing but the summation of the predicted value minus actual value for all the m terms. And we are doing that y hat minus y we take the sum for all the terms and we divide by m, and I will return this dwdv. Now here comes our training loop. Now we don't focus on these lines. Uh, Indeed, these lines, this is nothing but storing the updated values as we had done the same thing in the linear regression with single variable case. The main loop start here, in which what we do is we loop epoch for epoch. For each of the epoch, we calculate this dwdb using this grad function, which we defined here. It will return me dwdb. Okay, so we have calculated the dwdb in one go. Then we update the value of w as w is equal to w minus this learning rate times dw. We update b by b is equal to b minus learning rate times db. Then after updating, I calculate my predicted value of the for the updated values of w's and b's, and then I calculate the loss and just store some for plotting purposes. Okay, and we do this for the number of epochs, and we are done. Now we have defined our model class. Now let's implement this class on our data set. So this thing are all the same which we had just done. Now we apply the feature scaling. We will use standard scalar, and I also recommend the standard scalar or that min max scalar, because in standard scalar you get negative as well as positive values, which will give your model the flexibility to learn. Whereas in min max scalar, each column will be compressed to 0 and 1, which are positive values. So you are restricting the signs of your values. Okay, so I prefer using standard scalar. I fit on x, I transform the x. We are doing the same thing. And now once we have this x scaled ready, we convert our, since my x is in numpy array, we have to also convert our y, which was a pandas data frame, also to a numpy array. We convert it. These are my x and y. Now we had just created our class, which was named multivariate linear regression. Now we will create an object of that class by just we will give it the name as model. We will create an object of this class, and it takes just single input, which was the number of features, in which we can get this by x dot shape 1. Remember, if you put here 0, you will get the number of rows. If you put 1, you will get the number of columns. So we created our model. Now let's fit it on our data. This is nothing but where our training happens. So for that we give, as you can see, this fit function over here takes 4 inputs, which is the x, the y, the number of epochs, and the learning rate. So we give it x scaled y, the number of epochs is 200, the learning rate is 0.1, and here my model is trained. It just takes within a second to train, and here I'm plotting the values of loss after each epoch, and you can see just within 25 epochs our model has converged. Okay, and the final loss value is means at this point our loss, the final loss is 39 or something. And now I have plotted how each of the weights are learned. So see, the W was initialized to somewhere around 1, then it has learned, it has set itself to a value of 0, minus 3. Weight 1 has learned to minus 5, weight 2 has learned to somewhere about 3, weight 3 has learned to 3, weight 4 has squished to 0. Then the bias, this is the bias which has taken the value somewhere around 40. So once we have trained our model, let's do some testing. For that, I have created a user interface. Basically, I am taking from the user different values of houses, distance to the nearest metro station, convenience stores, longitude, latitude, and as you can see, we call this function, and here it will ask me to enter the values for each of these feature. I have already noted these values. I enter one by one, and it will give me the prediction, which is so the predicted value of the price of the house given the house which is this price, all these features. It predicts that the price will be 49. Okay, and how do we predict? So First, I create an empty list. I take the user input. So I have a list in which I have all the features values as like this. Then I am converting into an array. I am applying the scaling because our model our model expects that our inputs are scaled. So we are using the same scaled scalar object which we had fitted on our array to transform this array, and then we can give the prediction just by model.predict this scaled array. And yes, uh, we get the prediction. So here we are finished with the multivariate linear regression. There are two topics left, but let's ask Raj that what to do now.
Yeah, so I believe one is regularization is left, and
Yes,
what is the second part?
polynomial regression.
Yeah. So, guys, I would like you to let us know in the comments and also by showing the likes and the uh, video, so that we understand that you want more of this session. So, I would like to close it over here because it's getting a bit long over here.
Yes, yes.
So, while you guys are asking questions, I would just add this screen over here. So, while they are just asking questions over here, uh, what is the next thing they should be focusing on? Like, what is the next thing they should be working on to learn more about machine learning?
Okay. So if you are a beginner and this was your very first session on machine learning, in this session you have learned how gradient descent algorithm works. Now this gradient descent algorithm is used for basically all of the models. So once you understand gradient descent for this linear regression, you understand it for all of the available models. So
Mhm,
that thing is clear. Also, now you have developed an understanding that given any model, how the parameters are updated, how to set the learning rate, how you monitor the loss, whether your loss is overshooting or undershooting. And
mhm,
also, I suggest that you learn from various sources. For example, after regression, suppose I want to learn classification. So there is a model named support vector machines which is used in classification. So what you do is you learn this from multiple sources. You
mhm,
learn the theory from maybe YouTube or some course. Then you learn if you want to learn in more detail, you can have a look at the courses which are provided by famous universities like Stanford, which are available on YouTube. And after
mhm,
that you can just use Google or YouTube. You will find how to implement it using sklearn or something. So
mhm,
you are basically developing your theory part as well as your uh, coding part as well, and then you can apply it to your projects. If you have your own project to implement, you can apply your knowledge on your project and solve real world problems.
yeah. Okay. So this is kind of a modular base. So for a person who is just starting for like learning machine learning, so is there any particular resource you would suggest over there? You mentioned YouTube and Google over there. Any resources you used for like it was a major point where you understood that this is a good platform to learn
So
machine learning?
Uh, the first the first course which I would be recommending is the Coursera's machine learning course
Hmm.
by Andrew Ng. And also
Okay.
Andrew Ng has this year only launched his same machine learning course in Python. Earlier there was no coding part. This year he has launched the theory as well as assignments in Python language, which I think it is available on Stanford University's website. It is also available on YouTube. That's one thing. Also, I would recommend a book named Hands on Machine Learning with Scikit-learn. It is by O'Reilly publication. You can find it on Google. It's a very good book. And e- also, one thing, if you want to start with deep learning without going into machine learning, you can also do that. So there are a few courses in which you can directly start learning deep learning without uh, learning the machine learning. One of the course which I have gone through is the IIT Madras Deep Learning course, which is available on Google platform. It is a very incredible course. It is perfectly balanced course between the theory part as well as the coding part, and it is implemented in PyTorch language, PyTorch library, using PyTorch library. So you will also learn deep learning as well as PyTorch.
Okay, cool, cool, cool. So, yeah, so I would like to thank everyone viewing the video right now, and of course, Arjun. Thank you very much for the amazing session over here. So, guys, can we just have a appreciation for Arjun over here? Can we just have you guys subscribe to his channel? So he makes amazing videos over there, and it's just helping each other over here, and just to show your appreciation that it's a good session over here. So yeah, do
And
follow ML Guru, and
and
also we
also the
would be,
things
yeah,
we
sorry.
have which are pending is already available on my YouTube channel.
Mhm.
There I have already linked the code in the description box, so you can go through the channel and learn each topic we have discussed in detail. So today, in just 2 hours, I am not gone in much detail over there, but on my channel I have every topic covered in detail along with the code, so you can
Okay.
go there.
Awesome. So we also have the link attached in the description box. And also do follow DNC if you like this kind of session. We would be bringing such sessions with more experts on platform right now. Uh, Apart from that, any suggestions if you guys want to give, you could shoot us DM or tweet us, or just let us know on every we are basically on every platform. You could just let us know which talk do you want for next, and we would start hunting for the next expert for our session. And thank you guys. So if you want to be stay updated throughout what we are bringing in and what not, you could subscribe to the YouTube channel, and also connect us on Instagram and Twitter. Apart from that, your host over here, Raj, you could connect with me on LinkedIn, and also on Twitter and Instagram. And Arjun over here, Arjun is also helpful over there. He would be also connecting you with you on LinkedIn. So yeah, thank you guys. So anything, Arjun, do you want to add to the whole talk over here?
I first of all like to thank DNC to give me this opportunity to share my knowledge with the community,
Hmm.
and hope in future you will bring many experts in various fields just like this to share the knowledge. It is very grateful that you are offering all this workshop free of cost, because I think that knowledge must be imparted for free. Everyone should have access to high quality knowledge.
Yeah, thank you. You actually just said our tagline is basically providing knowledge to everyone at high quality. So thank you, Arjun, over here. We hope you guys like the stream over here. You could subscribe to ML Guru. We would be also sharing the documents and all the code in the description, so you can come back over here. Thank you, guys.